year. What about the test last
How do
year?
you do the special effects? I watched that video.
You did?
Yeah.
You guys say anything?
I just watched the video.
You can learn. Oh god. Wait, is this live? We're live?
Yeah,
Yeah.
we're live.
Oh wow.
And then we're in the class. Star.
Yeah, that's coming. So sweet.
I'm a YouTube guy.
Mr. J, when's your birthday?
Yeah, you're right.
What?
When's your birthday?
March.
March
Which what?
What? Is that right? You mean by tripod?
What year?
Yeah, I want to get you something actually.
Oh yeah, we show up for a tripod.
Another tripod?
Yeah, my tripod is kind of broken.
Yeah, right. Just chipping everything on the
Yeah, don't you like?
You get like
You
17 tripods.
like
We put
the
it on.
top of the line tripod is for CA.
Okay, so this part is kind of confusing, but it's not too bad. So we're gonna show you how this works. So this is some type of polynomial. Polynomial is basically f of x is equal to ax, and there are reasons I color code this. If you can color code this, it'll be pretty easy to read, but it's actually not bad to do. So, Jing, I need you to put a computer away. If you need to move your seat to the front, that's fine. So you can see better because I write kind of small today. So this one is f of x equal to a x to the n power plus b x to the n minus 1. The degree is going to go in descending order. Okay. Lenny, put your computer away. Alright. It's descending order. Cx to the n minus 2, which is going down 1 degree at a time. But sometimes you can go down 2 degrees or 3 degrees. You can have zeros in those terms. And the k, which is some type of constant at the end. So in general, the textbook is very similar to this format. The format maybe changed, depends on the textbook. It's basically just A, B, C. The n is going to go down 1 by 1. The k is some type of constant in the back. So the leading coefficient test, what's the leading coefficient test? The leading coefficient test is going to tell me something about the M behavior. What is the M behavior? M behavior is how they behave at the most left and most right. Okay, Jane, you want to switch your seat up to you so you can see? So here, we're going to talk about, there are two things. There's A here. The N is going to be in green. So we're going to talk about green here. And that's not green. I don't know what my green marker goes. Where?
There. You know, it's the orange one and then, yeah. Okay.
Thank you. So this one is going to be green A here, and this green is meant, this N, sorry. N is going to tell me some type of degree of the function. So it depends. If N is first degree, then it's going to be linear. N is 2 degrees, it's going to be quadratic. N equal to 3 degrees, it's going to be cubic. And N is equal to 4, it's going to be quartic. Okay. So here's what a lot of confusing part gets it, but it's not that intensive. It's actually pretty easy. I don't think you guys really want to touch each other, but. Whoa. Let's focus here. So there's a few cases possibility. It's that A is positive, A is negative, N is even, N is odd. So basically it's outskirt. So we are only looking at the one in the box right now. So whatever this here is going to be the one in the box. It's A to the X to the n, so we only pay attention to the n or a. We don't care about anything else after that, because that's not important. Now, when a is equal to positive, a is negative, n equal to even, n equal to odd. Now, we're going to start with the first situation. A is positive, n is even. Okay, you might want to write down stuff. A is equal to positive, n is equal to even. So now it's going to be 1, y is equal to 1x squared. That's the simplest case that you can think of. Because when even power, you're not going to have anything less than the 2. So 2 is the most even power, simplest even power I have. 1 is just regular positive 1. So therefore, your graph is going to be 1x squared, so it's a parabola facing up. Okay, so in this situation, let's look at here. So let's look at what does this mean. LIM stands for limits. Okay, guys, put your computer before I throw it outside. Serious about your computer. Yeah, thank you. So limit is equal to, LIM is limits. So what does this mean? This means limit x, this is arrow, going to, x is going to negative infinity. That means I'm going to this direction, going to the left. F of x is the y. So that means when x approaches to the left, what happened to the y? Okay, so x is going to the left because negative infinity, right? So this part left is this part. What happened to the y? What happened to the f of x? So limit x approach to negative infinity, positive infinity here, that means approaching to the what? Right. X is going to the right. What happened to the y value? So that is, this part is right. So in this case, that there was two situations here. So we're gonna show you how do we write this. And we're gonna erase this part. So we're gonna write those. We're gonna write it together. So we're gonna write it together. So if you could look at this function, if I look at this function, if I'm going to the left, what happened to the y value? Up, right? It's up to what? Well, we don't know because depending on how far I'm going, but we're saying we're going to negative infinity. So how high is it going to go? Positive infinity. So how do I write left in terms of math notation? It's going to be limit as x approach to negative infinity. I always write it start from the left. Just like when you're reading, it's left to right. Of f of x, okay? And then I also can write right also, so I can write both at the same time, so that way you don't get confused. Negative infinity of f of x. So you look at this function. It's going to the left, what happened to the function? Up, which is a positive infinity. What happened when we go to the right? Up. There we go, that's it. Okay? So that's the hardest part is to be able to write it in a mathematical way, is the end behavior. How do I write that in end behavior? Now for this, I can write it up, but for me, I'm not going to give you credit if you write up on your test. I want you to be able to write in terms of limits, because this is in pre-calc. In algebra 2, you write up, I'm okay with it, I can live with it. But I want you to be able to write it in pre-calculus way. Now, how do I write this one? Well, I always do the same thing. So everything they always go into the left, and then there's go into the right. So I always write this down first. To the left, to the right. Okay? So now what happened if I go into the left? The function is what? Down. So what will it be here?
Negative.
Negative what?
Infinity.
Negative infinity, that's it. As easy as that. Limit x approach to positive infinity of f of x is going down again. So if it's down, if you look at it, if the function going to the right, what happened to the y value? Down. So it's a negative infinity. Now, this graph is the easiest one I can memorize. I don't like to memorize all this crap. What I mean by crap is the actual memory is just storage to inside of my head, and I'd rather to focus on just the whatever inside here. So I understand the simplest graph, and I can picture this. Do you see what I'm saying?
Yeah.
So you don't try to memorize all this stuff. You just understand what the simplest graph represents. A is positive, n is even. How do I memorize the n is odd and the a is positive? Well, this is just like a simple graph. Y equal to x. We know that. You can do x cubed, but x cubed is a little bit of memorization in the waterfall graph. So what happened here? Can you finish writing here? Now, the same thing to write on all of them. X approach to negative infinity of f of x. It's always the same thing. Limit x approach to positive infinity of f of x. Okay? What do you think this is? Negative infinity, right? Does that make sense? How about going that way? The function going that way, the function is what?
Positive.
Positive. That's it. Now I'm going to go ahead and do the last one. What happened when limit x approach to negative infinity of f of x? Here, it's going to what? No.
Positive.
Positive infinity. Limit as x approach to positive infinity of f of x is equal to what?
Negative.
Negative infinity. And that's it. That's the leading coefficient test. And this cannot be anything easier. Okay? So we're gonna try a couple. So now we're gonna say, hey, let's give a shot with a couple of things that we have. So, oops. Guys, please not know. So we're gonna pick a function. Okay, we're gonna pick a function. And the function is gonna be like straight ratchet tripod we have. Okay, so well, we're gonna pick a type of function. You're gonna tell me what happened. So I'm gonna pick it as functions, and you're gonna tell me what is the end behavior. I want you to visualize the end behavior. So let's pick a number. Which number you like?
3.
17.
Okay, negative or positive?
Positive.
Positive 17, okay. So 17, x to the which power?
3.
X to...
The 6.
6, okay, let's go with 6.
No, it should be 5 because the Red Sox won game 5 against the Dodgers.
Oh, are they so tired? Okay, so let's go with 6. Okay, so some type of function like this, 17x to the 6, and plus 5x to the 3rd, and then plus 2x to the 1, something like that.
You get this?
Okay, so now, before I do this, I want you to predict what's going on. So let's look at here. This is which type of degree?
Positive.
It's not,
Six.
it's a positive degree, but what kind of degree is
Six.
decrease? 6, so is that even or odd? Even, right?
Even degree.
And then the 17 is a positive or negative?
Positive.
Positive. So we're gonna go to here. We're gonna go to the positive and even degrees. So that means is the both sides is gonna go
Up.
up. Yes.
Is that green A supposed to be green in the top at the beginning, or is it supposed to be red?
This A is.
No,
On
the
top of
first-
it. On
the
top of
F-
it.
That
At
should
the
be
start.
red. That should be red. You're right. Okay, so in this case, this one's even degree, right? This one's positive, so you know both ends is gonna be up, right? Does that make sense? Because if it's a negative 17, then it's gonna go what? Down, right? So here's what we're gonna see. So let's click and see the graph, see how they behave, okay? So let's go into here, 17. You see the graph of 2n, see this graph is keep on going up and keep on going up. Do you see that? And it doesn't matter what happened here. It doesn't matter if I change this to -3. It didn't change anything in the outskirt. It changed here, but it doesn't change in general how they behave at the end of the functions. At the end of the left function and end of the right function. Are we okay here? Now what if I want to change this 6 to 5? What will happen? What do you think the graph's going to do?
It's gonna go R because it's an odd number, right?
Go up.
Okay, so
Go up.
Go.
now I want you to look at it again. If I change this 6, change to 5, what will happen?
Look
It's
like
gonna
a
be odd, so it's gonna be different.
look like
It'll
a
be a
line.
straight line.
It does.
Well, it's not a straight line. The straight lines tell you how they behave at the end. So 17x to the 5th power is gonna go and behave as odd degree and positive. So what is odd degree and positive? Look at the chart.
Down, up.
Down, up. So let's look at it, see if that's true. So I'm gonna change this to 5. Down, up. Do you see that graph?
It looks like a waterfall.
It looks like almost a waterfall, but this side is gonna go to down, and this side is gonna go up. And I don't care about what happened in the middle. Middle is not important right now. The middle just to tell me, you know, I don't really care about what that part is. I only care about what happened in the middle part of it. The middle part is gonna go like this. But the outside part is gonna be down, up, just like a straight line. So straight line has a positive. What if I change it to 17 negative? What do you think the 17 if I change it to negative? What would the graph
Go
like?
flip.
Up, down.
Yeah.
Up, down.
It'll be
It'll
like-
be up, down, good, so. Do you see that? Don't look at the middle, just look at how they behave on the most left and most right. Do you see how they work now? Are we okay? Okay. So now pretty much you guys got an overview of all the things, how the end behavior is gonna do. So what we're gonna do is we're gonna name a new function. That function looks like this. So y is equal, so help me write it correctly. Y equal to 2x to the 4th minus ax squared. Okay, so can you tell me, write the correct way without looking at the chart? Okay, think about it at even degrees. You don't look at anything else, you only look at this part. Okay, you only look at this part.
It's gonna be up.
Up, up.
Up.
Okay, so y is equal to 2x to the 4th minus ax squared, right? So if it's up, how do I write it mathematically?
Oh.
Lim.
Lim.
X. X. Arrow, negative infinity.
Negative.
That means the function's reached from the left or right?
Left.
Left. Okay, and then we're gonna do the right also.
Go
Are we
for it.
okay here?
Yeah.
Equals
Positive.
positive.
Plus infinity.
And that's it.
I don't get it. I don't get it.
Okay, so first of all, you only pay attention to this
Yeah,
part.
I know, and not actually.
Yeah, some people. was like, okay.
Okay, so let's change this to red. So this part is red 2, and this part is the green 4. The 4 is the degree, which is the functions. The function is what? Even degrees. So therefore it's even degrees. And the A is a positive, so this is the only one that fits.
What would it
So
be, odd degree?
odd degree if it's 2x to the third.
Oh, like like odd number.
Yes.
Oh.
Like, I get that, I don't get the limit, or like, I don't know how you decide the X.
Limit.
Lim.
Okay, so yeah, it's called limit, you're right. So limit is saying this, Chris, wake up. Okay, so limit x approach to negative infinity. That means always reach for the left. We always start from like a reading, always reading from left to right, right? So I'm gonna analyze this left and right, always the same thing. This is the left, this is the right, means x approach to left infinity. What happened to the graph? 2x to the 4, that is gonna be positive infinity. Limit x approaching to positive infinity means to the right. What happened to the graph? Going up, because just think about this one, I would think about x squared graph. It's going up. If it's up, then it's positive, positive. So it's positive infinity, positive infinity. What happened to the y value? Positive infinity. Are we okay here?
It's the X approach. That's what I.
X approach to the negative infinity, that means x going to the left. Negative infinity is to the left. Now, so this is it means left. This means right. What happened to the function? Going up. What happened to the function? Going up. Look at x squared graph. Because look at the simplest thing is x squared graph. Are we okay here? Now let's determine, is this even or odd functions?
Wow. Oh, it's odd, it's odd. Symmetry to origin.
Are you sure?
Positive.
Okay, so how do I test if it's even or odd?
Negative.
Negative x, good.
Oh, we're gonna do that.
Yeah, we're gonna do that.
Wow. Even worse. Or better.
Okay, we're gonna do that. Y equal to negative x. So what I would do is we plug in negative x, whereas x is what, 2 times negative x squared minus 8 times negative x squared.
Isn't it 4?
4, good. So this one is gonna be 2 times x to the 4th minus 8 to the x squared. So that is still going back to original equation. So is that even or odd?
Even.
Even functions, right? What is even function symmetry of?
Symmetry to y-axis.
Y-axis.
Symmetry to y-axis, thank you. So now only that is symmetry to y-axis. So then you say, oh, okay, not understandable. Then you're gonna go back to look at what happened to other things. Symmetry to y-axis means left is equal to right. When you graph, you can graph left side of the function. You can have a mirror image to the right side of the function. Am I going too fast? Okay. So now let's go back to the normal thing. What happened to the x-intercept? And what happened to the y-intercept? Now let's go from y-intercept first. How do I find the y-intercept? How do I find y-intercept?
Look at 0 for X.
Replace x is equal to 0, right? With 0. Solve for y. 0. Solve for y. So how do I replace that? So it's going to be f of the 0 is equal to 2 times 0 to the 4th power minus 8 times 0 to the 2nd power. That's equal to what? 0.
So,
So 0, 0. And we already know 1 y-intercept. How do I find the x-intercept?
Y.
Y equal to 0. Good. So, no, x-intercept is
0 equals 2x to the power minus 3.
so x-intercept is 0 is equal to 2x to the 4th minus ax squared. Now the problem is, how do I find the x-intercept? It could be more than 1, so we're gonna say it's more than 1. So how many x-intercept do you think they are gonna have?
But one.
So how do I solve for this? Factor. So what is the first thing I'm factoring?
2.
2x2.
2x squared. Good. So I can say that's 2x squared. Factor out minus something. So 2x squared times 1 equal to x to the 4th. X squared. 2x squared times 1 equal to ax squared.
4.
Negative 4.
Negative 4. Good. So now, can I factor more? Oh. How do I factor this?
X minus 2, x plus 2.
Good. It's called difference of a square. So that's what we spent a lot of time very beginning of the year to build all the foundation we have right now. But what does that mean? That means, I'm going to write up here. That means 0 equal to 2x squared times x plus 2 times x minus 2. That means we can use something called zero product property. What is zero product property? Well, it's very like the name, zero product property. Zero product property. Okay, property. That means I can take each of the factor, set it equal to 0. Why? If I take this factor equal to 0, right? That's one of the 0, but some people say it's a 1 or 2, but it's actually 3. X equal to 0 here. What will happen if I plug in 2 here? If I plug in 2 minus 2 is what? 0. So it doesn't matter if I plug in here. 2 plus 2 is what? 4. 4 times 0 is what? 0. So that's why we said this factor equal to 0. That's the reason behind it. It's called zero product property, because anything multiplied by 0 is going to make it 0. So I only need to make one factor become 0, because factor you have to multiply at the end. So now I can do this one here. X plus 2 is equal to 0. What is it? X equal to negative 2, right? Not only that, the last one here, this part can equal to 0 as well. X equal to 0. There's 3 x-intercept because you have to set each factor equal to 0. Therefore, you find out all the x-intercept. So you need to learn how to factor from before. It's kind of a review now. Now you gotta factor if it's something you can factor more. So in this case, I can factor more. So they actually give you 3, 0. Matter of fact, I want to write in the from left to right order. If I write it from left to right, it makes more sense. So I'm going to rewrite this. I'm going to say, hey, I'm going to write it in the left to right. Negative 2, x equal to 0, x equal to 2, right? So I write it in the left to right order. And there are reasons how I'm doing that. Now we're going to talk about multiplicity. So I know this is a lot to talk about today, but we just get this one shot over. So tomorrow we're gonna have more like classwork that you can do. So you can make more sense. But today just have to focus as much as you can. So I'm gonna use a different marker here. This is invisible. What do you think invisible is what? What number is here?
1.
1. And then there's another one. What do you think the power is?
1.
What do you think this power is? 2, right? But this offers me something. This is an exponential exponent of the 0. This exponent of the 0. This exponent of this 0. This is something called multiplicity. So all this, they all have one name. It's called multiplicity. Okay? Multiplicity is how they behave at the particular 0. Basically, there are few possible situations. Andrea, I need you to pay attention. So let's write down what's the multiplicity here. So what do you think the multiplicity for the first one, does x equal to -2, is this one, right?
Yep.
What is the multiplicity here?
-2?
1.
Oh, 1, just 1?
It's the exponent.
Oh, just
Oh,
that?
good.
What is x equal to 0? What's the exponent there?
2.
2. What's the exponent here?
1.
Okay? Lenny, are we okay?
So the X-intercepts are to make the factors equal 0?
Yes.
Okay.
That's pretty easy because on SAT it does that all the time. It does that all the time. I promise you it does that all the time. Not only this, you're gonna say, okay, I got this. I'm ready to go to the next part. Now, what do I do? Well, you have to understand what's m equal to 1 mean. M equal to 1, that means, think about parent function. Which one's gonna m equal to 1? X equal to 1. So 1x. So how do they behave at that 0? They're just gonna shoot straight through. So m equal to 1 is a very easy thing. It's a line. And it's gonna go pierce through. I don't know how to spell pierce. Spear through, maybe. Spear. Spear through. Line, spear through. It's, when that line's gonna go straight through and not 0. That's how they behave. What do you think the m equal to 2 is gonna do? X to the second degree, what do you think that do at a 0?
Make it positive.
It curves.
Oh, wait.
It curves. How do they curve?
Oh.
It's a problem. Because m equal to 2 is what? Parabola, right? So we're gonna talk about this as part as a parabola. How to spell parabola? P-A-R-A-B-O-L-A. Okay, parabola, right? So I call it bounce. How does a parabola? Parabola is gonna hit that 0 and bounce it off, right? It's going like this. Does that make sense? Now m equal to 1 as it pierces through again, so it's a line. Spear through.
Pierce is spelled P-I-E-R-C-E.
P-I-E-R-C-E.
R-C-E.
So pierce through. So it's gonna shoot through that line. Okay? So that's how the thing that's gonna be kept. So how we're gonna analyze this. So now we're gonna analyze everything in combination. Okay, I know this is very difficult to understand, but just bear with me, you're gonna be okay. So we're gonna have a -2, we're gonna have a 2, and we're gonna have a 0. So, are we okay here? We're gonna write down all the m behavior. How do we write down m behavior? M behavior is this one, right? But we also know it's up, right? So if it's up, can I just draw it like this, up? We know at the end it's gonna be up. Lenny, wake up. So this part is gonna go up at the end. Okay? I know today is like very tired day. It's cold outside, Monday.
I know, it's killing us.
You just ate. It's really hard to stay awake. I had to pour water on some students.
Yours to me?
Okay, so anyway, so
Oh,
this part is going up. But what happened? When they come to this one, it had to come down, right? It has to go down, right? Because in order to reach 0, because this part's go up, this one has to come down. And not only come down, it has to shoot through. So this one's gonna shoot through here. It's gonna shoot through. I'm gonna write down m is equal to 1 here, and the m is equal to 2 here, and the m equal to 1 here, to show you how do they behave. So it's gonna shoot through here, and then it's gonna come back, because I eventually had to come back to the 0. The graph has to eventually come back to the 0. So when they come back, it's gonna go in like this. So that's the graph, maybe that's a sketch. It's not a real graph, it's going to be like, so the m equal to 1 is gonna pierce through that 0. M equal to 2 is gonna have a second degree function, but since on the bottom that u is gonna be inverted, because that is gonna be a bounce off action, and then it's gonna spear through again, and it's follow the m behavior. And if you check the m behavior is right, in the middle part, just double check, are they follow the multiplicity? Once you do that, your graph is gonna be phenomenal. Your graph is gonna come out as close as possible here. So let's look at here, what the actual graph look like. Y equal to 2x to the 4th minus 8x to the 2nd.
Wow.
How would you know how far down it goes?
We don't know how far it down goes, but this is a pretty close estimation. So I will make it even closer here. So let's go with a -5, 2, 5. And let's go with a -20. So it looks like that, -20. So it's gonna look like this. And this is how, if I scale it different, it looks like almost the same as my prediction. But not only almost the same, so we're gonna do it this side. So only like look at this part. This is that 0. What do they do? N equal to 1, they behave like a line. It's almost look like it's a straight line. As crazy as that, as I look at a straight line, just like this part is going straight through, right?
Oh, wow.
And then let's go to the 0 and see what happened. Let's go to the 0 and see what happened. It looks like a parabola. It looks like a parabola that's going up downwards. And I don't need a decimal to really tell the graph how the graph's gonna go. This looks like a straight line. That's how they behave. That's how they behave in particular. Are we okay here? So we just factor as much as we can, and we determine that 0, and we determine from 0 from the left to right, left 0 to the right 0. Throw in the m behavior in there, and then see what's going on. So right now, we're gonna give you something a little bit easier to work with. We're gonna give you a factor form, but then you have to understand a little bit more. So let's deal with the factor form, and that's tell me what happened the 0 is. We're gonna work together. I don't know how much time we have.
Yeah, like 9.
10 minutes, literally.
Good.
So Mr. the thing that was on the test, right?
Yeah.
You don't have to be completely accurate with your graphs?
It had to be some information I asked you. You had to give me a complete information, but some information, most of the information you know. So we're gonna show you what information I really want. So I'm gonna give you some type of factor form, and you're gonna tell me if it's right.
So like the X-intercept you would want right?
Yes, that's for sure. So let's give you this one, but we're gonna give you something called factor form, and let's see, this is a little bit easier to work with. Because that has nothing to do with math, just knowing how the graph works. So let's do x plus 5 to the first power. And we're gonna put a negative sign in the front, just make it kind of fun. And maybe x plus 1 to the square. And then x minus 3 to the third. Okay, so there's like here. This is called factor form of polynomial. Why is this factor form? If I were to expand this, if I FOIL this and I FOIL this, distribute this, and then distribute everything together, it's gonna be a very long polynomial. It's really disgusting. It takes about 5-6 minutes to do, even with me. So I won't want to do this, but we're gonna teach you how to shortcut. Since we only care about, what do we only care about? The first one. So we don't need to worry about what happened 5 multiplied by x. We don't need to worry about 5 times 1. We only worry about just the x. So we just care about this. So let's cut our work down short. The negative sign is still going to be there. And let's just assume that it doesn't have 5 in there because we only care about the first term. So we just only multiply the first term, which is x to the first power. Are we okay here? What happened to x to the what?
Second power.
Second power. X to the third power. So if I multiply, just look at leading coefficient alone, what do you think the final power is going to be?
Negative x to the 6.
X to the 6, because the power is going to add. 1 plus 2 plus 3, that's equal to negative x to the 6. Are we going too fast? So what do you think my leading coefficient test is going to be? Now looking at this, can you tell me what's the closest thing that comes to negative x to the 6?
Down.
It's down. Good. How do you know that?
Even.
Because it's even.
Even degree,
negative.
this is negative.
Yeah.
So just like remember this graph, right? For me, I don't remember this chart. I draw a chart for you to show you, but this one's look like this. So, and I will write it, again, x approaches negative infinity, limit x approach to positive infinity of f of x, this just means left and right. Is down is negative infinity. That's how to write it correctly. Now again, this is a down situation. Okay, so it's down.
What is in front of that?
Which one? Here? Limit x approach to negative infinity. Limit x approach to positive infinity. That makes negative infinity. Yes.
Limit?
Okay, so now we're gonna say, okay, that's good. Let's go and find all the zeros. So let's find y-intercept. So what is y-intercept? Y-intercept is x is equal to 0, right? So how do I do that? So it's like f of 0 here. F of 0 is equal to negative 0 plus 5 to the 1, 0 plus 1, and the 0 minus 3, right? So that's equal to what? Second power to the third power. This is a very, very huge number, but this one's going to be 5 times 1 times 3 to the third is 27. Are we okay here? I just plug in 0 for this function. And then I'm going to get negative 135, I think. A negative 135. So it's going to go below x-axis for a long time. Nicholas, pay attention to up here. How do I find y-intercept? X-intercept, sorry, x-intercept.
Make X 0.
No, make the y go to 0.
Sorry, why you?
Right? So what do you think is here? X plus 5 is equal to 0, right? X plus 1 is equal to 0, x minus 3 is equal to 0, x equal to what?
Negative 5, negative 1, positive 3.
Are we okay? What's multiplicity?
1, 2, and 3.
So m is equal to 1, m is equal to 2, m is equal to 3. I think this part you learned it last year, right? Advanced topic. Advanced topic, you should learn this already.
I never took advanced topics.
Are we okay here? So now we're gonna draw it. What are we gonna draw? Well, we're gonna draw the y-intercept. What is the y-intercept? Do I really care how far down low, below? I don't really care, so we're gonna say this is negative 135. And this is probably some points going through here. What x-intercept we have?
1.
Negative 5,
Oh wait, yeah, negative 5.
negative 1,
And 3.
m is equal to 3, so that's gonna be like this. What's the multiplicity here? 1,
2,
2,
3.
and 3. Okay, what does the m behavior is gonna do? Down, right? Down, right? Down. So now we're gonna draw it, we're gonna sketch it. So if this part is going from the down, it's gonna go through this part, m equal to 1, that means what? Going through it. Okay, going through it. But it's gonna come back to this 0 though. Something I did wrong. Oh, this one's minus 27. My bad. This one's 135. This one's a positive 135. So this one negative. So again, you can double check that. You can say, oh yeah, that's wrong because negative 3 to the third power is negative 27. So it's gonna go through, right? What happened when when it's gonna come back down to hit this point? What happened at m equal to 2?
What happened?
It's a parabola, it's gonna be a bounce, right? So it's gonna be something like this, it's gonna be going here, a bounce. And it's gonna go through here, right? Now m equal to 3, what is m equal to 3?
Waterfall?
It's a waterfall, good. But the waterfall is going this way because it's gonna go the negative waterfall, so it's gonna be like this. So that is in general, what a graph, we don't know how high it's gonna go, we don't know how low it's gonna go, but we're gonna graph. So we're gonna try this graph on the decimal, we're gonna see what happens. Is that go with our aspect or go different? So, negative, parentheses, negative x minus what? X plus 5. And then what? X plus 1.
To the second power.
Minus 3 to the third power.
X minus 3
To the third power.
to the third power. Okay, so now we're gonna set this a little bit different. But in general, we look at the original graph. So we're gonna turn off the light. In general, it looks very much how they behave. Look at this part; they behave like a line. This part they behave like a parabola. And how high is 135? And here looks like waterfall. So we're gonna pay attention to that. So we're gonna change the aspect of this. So it's -6 to +6, and then this one's gonna be positive, maybe 150, and this one may be negative 50. So maybe negative 2,000. So if you see that, it's still not high enough at this part. So this side is really, really high. So, but you just see how they behave at this 0. Look at this 0. Look at this part. They go in straight through, right? And look at here, which is x equal to 1. That's going to look like a problem. And then look at this part. It's going to be waterfall. That's the waterfall.